guys, this is the next video in chapter 1, and it's entitled Units, where we talk all about units and why they're important. So the first system of units that I want to talk about is the SI units, the International System of Units. Now you can see not everything's covered, and this isn't all of the SI units by a very long shot, but it covers a lot of bases, mass, length, time, temperature, etc. A couple things I want to point out here. Kelvin is the SI unit for temperature, and kilogram is the SI unit for mass. SI unit is kind of what we think about whenever we think of scientific units, even though we use metric most of the time for things like volume and stuff like that. We don't really talk about meters cubed very often for volume or anything like that. So that's the SI units. Now, why do we care? Why do we care about units? Well, you probably at some point in your educational history said this, and your teacher looked at you funny and said, well, how do I know, this isn't 42 monkeys or fish or whatever? Well, to put it gently, or to put it, I guess, bluntly, you have to have units to understand what you're dealing with. For example, let's say you're buying steel, and I don't know how many of you know the price of steel, but you buy a chunk of steel, and the person that's checking you out says it'll be $250. $250 to what are we talking about? Are we talking about 250 cents? Are we talking about $2.50? Are we talking about $250? Without units, you don't know. And it's the same thing with chemistry. If you don't put the full unit, we never know what we're talking about. And it's going to be really important to write the full unit out whenever we talk about dimensional analysis, and especially in chapter 3 and 4, whenever we're dealing with stoichiometry. So the unit is incredibly important to us as a reader to tell what we're talking about, but also for you as a student, because it helps you keep track of what you're doing. One of the most important things in chemistry is simply unit conversion. If you can convert units successfully and confidently, you can very easily be successful in chemistry. And the reason for that is that most everything we do requires units. And if you can cancel units out and work with units, chemistry suddenly becomes a whole heck of a lot easier. Now, we talked about the SI unit or SI system, and we said that we use the metric system. Now, here in the United States, we have this terrible system called the English system. Now, I want you to look at all of those different units. How many of you have ordered a gill before? Right there, it's a fourth of a pint. Or a furlong. How many of you have ran a furlong? Eighth of a mile. It's not a great system, and we don't really use those in the United States. We more talk about pints and quarts and gallons and pounds and ounces and miles and feet and yards and all that jazz. There's only 3 countries left in the world that actually don't use the metric system. We, of course, are one of them. Now, so we don't use them in science. Besides this chapter, you're never going to see them again. Maybe a bonus question or something like that at the most. But we will talk about how to convert in this chapter. But know that the English system of measurement is objectively terrible, right? There's all sorts of, it's not based on anything. There's all sorts of odd conversions, 3 feet to a yard, 12 inches to a foot. There's no coherency. Whereas the metric system is all based on the power of 10, right? There's prefixes for our unit that tell us how big it is. And if you look on your screen, those are our prefixes. Giga to femtone. You're going to have to memorize these. You're going to have to know these for your test on this chapter. And just as we continue forward, I may give you wavelength in chapter 6 in nanometers, and you have to know what that is. Now, I want to point something out, speaking of nano. So this thing over here, this meaning column, tells us the base power as it's compared to our 10 to the 0, or our basic unit. So what we mean here, when we say nano is 10 to the negative 9, that means 10 to the negative 9, we're going to say meters or grams or whatever, 10 to the negative 9 meters is equal to 1 nanometer. Now that's nice and all, but most of the time what we use this, or what we refer to this, is backwards. How we refer to our nanometers to meter conversion is backwards. So we say that yes, that's correct, but we can also say that 1 meter is equal to 10 to the 9 nanometers. Just that exponent flipped around. And if we want to look at y, 10 to the negative 9, right? 10 to the negative 9. And if you remember our talk on exponents, this is 10 to the 0 minus 10 to the minus negative 9, which gives me 10 to the 9. So that's our conversion there. So don't get ever confused. Don't ever say there's 10 to the negative 9 nanometers in a meter. And you can always get it right if you think about it. Okay, a nanometer is very small, incredibly small. A micrometer, super small. Micrograms are very difficult to even measure. So it doesn't make sense if there's 10 to the negative 6 micrograms in a gram, right? 10 to the negative 6 is a very small number. It does make sense the other way, that there's 10 to the negative 6 grams in a microgram, okay? So always think about them logically in your mind, okay? A kilometer, okay? A kilometer is a really long distance, right? So it doesn't make sense if you said that there's 1,000 kilometers in a meter, right? That is 1,000 meters in a kilometer. Now you're going to have to work with this chart, and you're going to have to memorize it, but always keep in mind that logical way of thinking. Always think about, does my answer make sense? Does my conversion make sense? And whenever we get to dimensional analysis, we'll talk about how to plug these in to convert units, but always keep that in mind. The fact that we have smaller units and bigger units, and make sure that your number, the notation that you put with them, makes logical sense. We know centimeters are tiny, right? So that doesn't make sense that there's 0.01, which is 10 to the negative 2, 0.01 centimeters in a meter. But there is 0.01 meters in 1 centimeter, or 100, 10 to the 2, centimeters in 1 meter. Okay. Now converting between the two, look at all of those crazy conversions. Now don't freak out, there's a ton of them, but the nice thing about conversions is that we only have to know one for each type. The ones I recommend memorizing are these right here: 2.54 centimeters in an inch, 1.057 quarts to a liter, or down here you've got a couple options, but 453.6 grams to a pound. You could also say 2.202 pounds to a kilogram. The nice thing is we can always convert to these units and then convert over to metric and then go wherever you want as far as that goes. But you do need to memorize at least one for each unit: 1.057 quarts to a liter, 2.54 centimeters to an inch, and 453.6 grams to a pound. Make sure you have those memorized. And that's all you need to do. You don't have to memorize any of these other crazy ones, because we can always convert from one place to another. The temperature can be thought of as a measure of molecular motion, as a movement of molecules in a sample. Kelvin, as we said before, is our SI unit for temperature, and it is based off of this idea that we have motion of molecules. So 0 Kelvin, absolute zero, that's what that's called, 0 Kelvin. It's the coldest temperature you can get, coldest in quotation marks. Absolute zero, 0 Kelvin is the temperature at which there's no movement on a molecular scale or an atomic scale. There's no atomic movement. So we see our conversion here, that Kelvin equals our degrees Celsius plus 273.15. Okay, 273.15. So that's something that you're going to have to know, especially for chapter 10. For our gas laws chapter, we have to use Kelvin all the time, so you kind of need to know that. Now, the temperature that we're used to using is Celsius or Fahrenheit. Fahrenheit being the English measurement for temperature, which is not used ever in scientific measurements. It's a terrible unit, and you probably won't see it again after this chapter. But Celsius is the one we normally use because it's very easy to work with at normal standard temperatures. So as you can see, our conversion factors here, okay, we have our equations. It's very important that you get the parentheses correct, because again, if you don't follow the order of operations and you don't have these parentheses, you're going to get the wrong answer. So make sure you have these equations memorized in the correct form. And it's very easy. You just plug in your degrees Celsius or degrees Fahrenheit. Not too bad. Make sure to keep into account or keep in mind significant figures. Anyway, that's our discussion on units and why they're important, and some things about temperature. We'll talk about next time unit conversions and dimensional analysis and how we do that. So until next time, I'll see you guys in class.